Hey, it's Paris. You know I love sparkly things, right? Like stars. Duh. And thanks to Hilton and AutoCamp, I just slept under them. Picture me, serving looks by the fire outside my luxurious Airstream, making s'mores with the kids, while a national park is our backdrop. The great outdoors meets Hilton hospitality. That's hot. Explore all the new ways to stay at Hilton.com. Hilton for the stay.
This episode is brought to you by Indeed. When your computer breaks, you don't wait for it to magically start working again. You fix the problem. So why wait to hire the people your company desperately needs? Use Indeed's sponsored jobs to hire top talent fast. And even better, you only pay for results. There's no need to wait. Speed up your hiring with a $75 sponsored job credit at Indeed.com/podcast. Terms and conditions apply.
If you are interested in supporting this podcast and at the same time getting all my episodes ad-free, then please head to my website, 3dprintingbasicspod.com. Again, that's 3dprintingbasicspod.com. There you can find all the links to support me, my affiliate links, and as a perk, you can get all my episodes ad-free if you subscribe on Patreon, Spotify, or Apple Music. Again, all my links will be there, as well as a contact form if you have any questions. Thank you, and I hope you enjoy this episode. Hello, and welcome back to 3D Printing Basics. This is episode number 66, and in this episode, we are going to be talking about a very special filament, carbon fiber nylon, or PA-CF. This is a very, very tough filament to work with, but if you can print it right, then you're going to get one of the stronger printed parts that you can get with any 3D printing filament. I just used it for the first time a few weeks ago, and now I wanted to talk about it. So with that being said, let's jump right into today's episode. To start, let's talk about what is carbon fiber nylon. And it's exactly what it sounds like. It is a mix of carbon fiber and nylon filament, but the main piece to this filament is nylon, which gives it a strong, flexible, abrasion-resistant base. It's a really, really solid filament. If you just wanted to print nylon, you could, and it would work very, very well for most of these industrial applications, or if you needed something very, very strong. But to give it a little bit of extra rigidity, they add chopped carbon fibers into the nylon, and that creates that carbon fiber nylon combination. And the chopped fibers are added to stiffen the nylon. They help reduce warping, and they boost what is called dimensional stability, which means it doesn't shrink as much when you print it or expand or anything like that. It will keep its shape regardless of the temperatures and pressures that it is subjected to. And there are two main kinds of carbon fiber nylon. It's called PA6 carbon fiber and PA12 carbon fiber. And the difference is that PA6 is known to have a higher strength and stiffness, but on the other hand, it does have a higher moisture absorption, and that's probably the biggest issue with printing carbon fiber nylon is the moisture absorption. You need to keep it super, super dry, because if you leave it out for even 15 minutes, it's going to absorb all the moisture in the air, and that's going to really badly affect print quality. But we're going to talk about that later. PA6 is generally a lower cost than PA12, and it's used for things like automotive parts, electrical components, and general engineering applications. Whereas PA12, you're going to have greater flexibility and impact resistance. So if you're using something for crash tests or something that's going to be taking a beating, you might want to consider PA12. It is better at having a lower moisture absorption, so you could leave it out and it would end up better than leaving the PA6 out. It's not going to absorb as much moisture in the air. It has better dimensional stability, but all of this comes at a higher cost. So those are the main differences between PA6 and PA12. My personal experience, I've only used PA6 and I have not used PA12 yet, but I am hoping to do that. But those are the main differences between those two. And they're good for a lot of use cases, pretty much anything that involves extreme strength or extreme heat. The part that I used it on recently was a customer came to me and they wanted a motor mount for a boat to be printed, and they wanted to use carbon fiber nylon because the motor was, I believe it was at least a pound. It was a big motor, and they needed it to be super strong and be able to be outside in the hot sun or out on the water getting splashed and still being able to hold up to those elements while not changing or warping or weakening in any kind of way. So they wanted to use carbon fiber nylon, and it worked really well, I would say. It printed. The biggest problem that I had was bed adhesion, which we will talk about later. So it took me a couple tries to dial that in, but once I did, I was able to get a very, very strong print. It didn't look great. Surface quality when you're using PA carbon fiber or carbon fiber nylon is not fantastic. You aren't going to be getting a print that looks super beautiful with super clean lines, super clean layers, but you are going to be getting something that's extremely strong. So that's kind of what you sacrifice there is the looks of it for the extreme strength. This episode is brought to you by PCBWay. Ready to take your electronics projects to the next level? PCBWay offers everything you need, from custom PCBs to 3D printing and even CNC machining, all under one roof. They're trusted by engineers and makers worldwide for their exceptional quality and fast turnaround. And here's a special deal for listeners of 3D Printing Basics. Use the promo code 3D Printing Squared, SQUARED, to get $10 off your first order. Start your next project with PCBWay and see the difference for yourself. Head over to PCBWay.com today. All right, let's move on to the printing requirements for this. So first and foremost, if you're using carbon fiber nylon, drying the filament is absolutely critical. I did not do this the first couple of times that I tried to use it. I pulled it right out of the vacuum sealed bag, and that worked just fine. The first couple prints went well, but after that, I tried to do it again, and it was just absolutely horrendous. It absorbed all the moisture in the air, and there was bubbles everywhere. There was voids in the print. There were blobs everywhere. So drying is absolutely critical. From my research, it looks like it's recommended to do at least 6 hours in a 70 degrees Celsius filament dryer. So something along those lines. I've heard people leave them for days at a time to get it to where they want. So drying is absolutely super critical if you're ever going to use it. If you have a roll that you've kind of stashed away, even if it's in a vacuum sealed bag, I would still recommend drying the filament because, like I said, that's super, super important. The next thing that you want to make sure that you have is a hardened steel nozzle, and if you can, a hardened extruder gear. So a hardened steel nozzle is going to be very, very important because if you're using anything other than that, the carbon fiber, the chopped carbon fibers in there is going to wear away your nozzle and ruin the dimensional accuracy that you are trying to get, because it's going to wear down that opening of the nozzle. It's going to make it bigger than the printer thinks it is, and so it's going to either under extrude, over extrude. It becomes unpredictable once it starts doing that, but it is going to ruin the print as well as that nozzle. You won't be able to use it again. Now, the hardened extruder gears are not necessary. I was able to get away with using non-hardened extruder gears, but that's definitely something that helps or can help because the filament itself is very rough and very abrasive. So it could wear down, if you're printing a ton of carbon fiber nylon, it could wear down your non-hardened extruder gears. But that's, like I said, that's not a super necessity, but a super necessity is in fact the hardened steel nozzle. So make sure you get one of those before you start printing your carbon fiber nylon. Now for print settings, I was printing at 300 degrees Celsius and 70 degrees bed temperature. Almost all of the filaments recommend a 100 degree bed temp, but I could not get good layer adhesion and my prints kept popping off the bed when I was doing that. So after some research and looking online at some forums, I dropped the bed temperature to 70 degrees and used Magigoo bed adhesive glue, which is just a bed glue. You could use glue stick. The Bamboo Labs has their own. I'm sure you can find different ones out there, but I would recommend Magigoo just because it's the main one. It's the thing that everybody kind of uses. So I got a lot of success when I was doing that, so I would highly recommend going with a lower bed temperature than recommended and using a bed adhesion glue of some kind, just because that kind of was able to make everything stick and give me a successful print. Whereas if I did the higher bed temperature, then it just wasn't working. And what I also did to help was I lowered the recommended volumetric flow rate from 8 millimeters cubed to 6 millimeters cubed. And this makes the print take a lot longer, but overall it helped with the success of the print. I'm not sure how much it helped with the quality and the detail and everything turning out a lot better, but what I do know is that I was running at 8 millimeters cubed, and I was getting a lot of problems with prints popping up, and then the nozzle would hit it and that would just dislodge everything. And so once I dropped the bed temperature and the volumetric flow rate down, I was able to have successful printing. Every single time that I used those settings, I was able to get a successful print. Another thing that you're definitely going to want to consider is having an enclosed print chamber. That is definitely going to help when you're using any kind of high temperature filaments, whether it's ASA, ABS, carbon fiber nylon, regular nylon, just anything that requires a nozzle temperature of anywhere from 250 above, really, and a bed temperature of 70 degrees or above. You're going to want to use the enclosure and have a heated chamber, because that's going to really help with that layer adhesion in order to make sure that you get a successful print. So that's kind of all the different printing requirements that I would suggest when printing. This is the exact settings that I used, and I had a print enclosure and it worked great. It came out really nice. Like I said, it wasn't the prettiest print that I've ever seen in my life. I've seen a lot better in terms of not having any blobs or zits or anything like that, but it was easy enough to sand it down because this material is so hard. You can just sand it. You can even use a regular wood sander if you wanted to and sand it down. But once I did that, it looked just fine. And I'm not going to say it looked amazing. It looked just fine, and more importantly, it was functional, which was the biggest thing when you're using these high strength materials, is you want them to be functional. So that's kind of what I'm prioritizing when I'm using these higher temperature filaments. Is I don't really care about how it looks, because most of the time they're being used for a super specific industrial application, and so I just want them to work. And so whatever I can do to make them work, that's the big thing that I'm looking for. And so the last thing that I kind of want to talk about is it worth it for a hobbyist to turn to carbon fiber nylon as opposed to maybe some other materials that are easier to print, like PETG, maybe ABS or ASA? And I would say it's useful in its own right. I don't know if it's worth it. In my opinion, I feel like there are lots of other filaments out there that are much easier to work with and easier to print for the hobbyist rather than carbon fiber nylon. Like ASA is my go-to example. I use it for all the automotive parts that I make, and it works great. It's got high strength, super high temperature resistance, and it prints a lot easier than the carbon fiber nylon. I don't need to worry about constantly having it dried or anything like that. It just works. It works every time. There's nothing to worry about there. So I would say, unless you are having a super high strength part that you are going to need, like something that is going to be constantly in super high temperatures or constantly under super high stress, then I don't think you really need carbon fiber nylon. It works great for me as something that I can offer to my customers, because they do have those situations where they need something that is super high strength or needs to be able to resist super high temperatures. But if you're just a hobbyist and you're not doing it for other people and you're just doing it for fun, I wouldn't suggest using carbon fiber nylon. Just the headache of trying to ensure that you get super high quality prints out of it may not be worth the added strength that you get, especially when there are other filaments that are easier to work with out there. But with that being said, it still is a very useful filament. Like I said, if you have the extreme needs that this filament is made for, I would definitely recommend it, because if you are able to get a successful print, it is going to be one of the stronger 3D prints that you will ever make in your lifetime. And with that being said, that's all I have for you guys today. I hope you guys were able to learn something about carbon fiber nylon, and maybe you'll even be interested in trying it out for your next printing project. Thank you guys so much for listening and supporting the podcast. I really appreciate it, and I'll talk to you next time.